Hey everyone, my name is Mars, and today I'm going to cover shell scripting. I always found shell scripting really interesting, and by making this video I wanted to introduce more people into what shell scripting is, or at least teach them the gist of what shell scripting is. So because this video is not going to be that long, obviously I won't go into depth into everything, but hopefully you learn something new. I also want to make some disclaimers. I am going to be introducing some new tools, and as a beginner, this might seem overwhelming, but from my perspective, the way I learned these tools was by having someone use them first, in a video and a tutorial, and then I would pick them up for myself. So hopefully, if you want to do the same as me, you can pick these videos up. And as always, man is your best friend. And if you don't know what that is, I will introduce in a bit. I also want to introduce this video because in case you are busy, in case you want to see something else, I would always recommend seeing the video AT&T Archives, the Unix operating system, because I think it's an amazing video, and everyone who uses Linux should probably see it, because it just summarizes what Linux and shell scripting is in a way, in a complete, concise way. And that's what I'm going to attempt to do here as well, but I would always recommend that video. So now let's get started. So what exactly is shell scripting? I think a lot of people have a misconception on what shell scripting is because it's a very general, loose term. But to me, shell scripting is just basically a program that runs in a shell. And due to the capabilities of what you can do in a shell, the possibilities with shell scripting are also limitless. For example, if you wanted to print out a specific phrase or word from a file/text, you can do that. You can manipulate the file in whatever way you want to get the output you want. If you're a system admin or a user that really wants to check on their computer when something is wrong, or get notified when something is wrong, you can use a shell script to, notify you in the specific environment you want. And like I alluded, task automation is it's made more simpler with shell scripting. And these are all the things that you can do with shell scripting, which is why I suggest people to learn them, because it's useful. So like I said, shell scripting is a very general, loose term. And the reason is because you can use a lot of languages to write shell scripts. There are a lot of people who use Python, but there are even some that I know of that use Dart to write shell scripts. But this video is specifically going to focus on Bash. And I kind of made this table just to show off that there are a lot of, programs or shells you can use to write shell scripts. But I do want to make a disclaimer that basically you would hear a lot of people say, I use Bash, I use CSH, I use Fish to do something. And the main difference between these shells are mainly the features that they provide to the user. It's not really hard to write your own shell. In fact, if you want to, it's a very nice exercise to do. But the features you can provide are kind of the selling point. But many people use SH and its derivatives, which is Bash is included, because it's the standard. And that's the only reason why. So before moving on, I just wanted to make sure we're speaking the same language. So I just wanted to review/emphasize these words. So a shell is basically a program that allows you to connect to your OS through a text-based interface. And a shell is usually inside a terminal emulator, which is just an emulator that mimics an old TTY setup. And in case you don't know what a TTY is, it's basically an old computer that has a keyboard and a sort of a way to display what command you're running on. A command line prompt is just the line you're writing on to have your command run on. And the command prompt is just this little part which you can customize a lot. Finally, a terminal user interface is a way, a term people use. It's kind of like a GUI, which is a graphical user interface. So basically, instead of having an application or program run on a GUI, you would have it run on your terminal. So just to emphasize all these things, For example, I am using right now the shell CSH, and inside it, or I am running it alongside the terminal emulator Alacrity. So now that we have reviewed the most basic vocabulary, I also want to take a look at piping and redirection. This is because I believe that piping and redirection are the foundation of what makes shell scripting, well, shell scripting. To start off, piping is just basically taking the input of a program, taking the output of a program, and making it the input of another. So for example, let's say we have a requirement that we want to list the contents of our current working directory, but in reverse order. A simple way to do this would be to start with ls, because ls kind of lists the contents of the directory, but in alphabetical order as they appear. So C to W, left to right. But now we also want to do it in reverse order, right? So by using piping, we're going to do this. We're going to do ls, and then we're going to use the pipe or the bar, what we call this piping, or we call this a pipe, and we're going to feed the output of ls into the program sort with the R flag. The R flag just tells sort to do it in reverse order. So now as we do this, we can see that we got in, the output of ls, but in reverse order. And this kind of what makes piping so nice is that instead of rewriting the defaults of ls, we can kind of just by chaining multiple commands, we can kind of get the output we want. So for example, if we wanted to increase our requirements to not only do it in reverse order, but make it all capitalized, we can do that as well, and just keep using the outputs of all the previous commands and adding two more to it. So the way we're going to do this by doing ls-sort-r, and then we're going to have another command called tr, and tr is just a utility that allows us to do something like this. We do dot lower and then dot upper. It's gonna take every character and make it the uppercase version of it. So now that we click it, as you can see, we have a capitalized reverse order. And that's one of the most basic examples of just piping. So now that we move on to piping, I want to talk about redirection. And redirection is basically taking the input of something and changing it to somewhere else. And we kind of did that with piping already. If you didn't see, we redirected output of ls to sort, and then sort to tr, and we kind of did that. And in a way, you're also kind of doing just writing my ls, because when you write ls, we're actually getting the output of ls to standard out. And that is kind of by default, and it's kind of printing out to your your terminal. But the way redirection is usually taught is actually by doing something like this, where we do ls and then we use the close square brackets, and then redirect the output of ls to a file. Let's just use something like files.txt. So now once we do cat files.txt, we can see that we got in the output of everything. And if you're wondering, yeah, we can pipe and redirect at the same time. So if we go all the way back and look at our command, again, a capitalize a reverse order, we can just redirect this also to files.txt. But here's a little problem. If we just do the normal closing square bracket, it's going to rewrite the whole file. So if, for example, you don't want to rewrite the whole thing, and instead you want to, append to it, add to the existing file, we can do double close square brackets and list the same file. And now once we do files.txt, as you can see, there are all the things we want. Sorry, my terminal's a bit small in this thing. Before we move on to that, however, I kind of want to look at more examples of piping and redirection. And I'll cover standard error a bit later. So for example, what if we wanted to find all files ending with a certain extension, selecting one, and then starting in my text editor? Let's take a look at how we're going to do that. So to do this, I'm going to use a command called, or a utility called fd. So if we run fd, we're basically going to get all the files I have in my hard drive. And to be more specific about what files I kind of want to print out in a terminal, I can do like fd-e, which the E stands for extension. So basically here we're telling fd to only find files with some sort of extension. And the extension we're going to look for is rs, right? And rs stands for Rus. So I'm going to look at all of my Rus files in my hard drive. And you can see this is a long list, and I kind of don't want to take a look at all these files. So as I said, in our requirements, or made up requirements, I said that we're going to look at all the files and we're going to select one. And to select one, I'm going to use a program called FCF. And FCF allows me to FCF kind of takes all the inputs we gave it and allows us to kind of gives us, I guess, this new interactive selection. So if we do something like main.rs, we can see all the files that are with that and with main.rs, and then it tries to locate all the files that are after it. So for example, we wanted to search up for a file called web.rs. We click enter, and there we go. We pipe all this long list into this specific example, or this specific file. But that's not the end to our requirements wanted to start in a text editor. So I guess a native approach would be to pipe it into just your text editor. In this case, my text editor is going to be NeoVim. So if I pipe the file directly to NeoVim, it's not going to be happy. You know, it didn't really start the file, and it doesn't really know what's up. So if we take a look at that again, right? So usually what we would like to see is just if we print, I guess, copy everything here and then do NeoVim and then just put in the file as an argument to NeoVim, it would automatically start. And that's how we want it. Unfortunately, that wasn't the result we got. And as it turns out, some programs give you a file, like in that example. And what we would like to do, instead of piping, we would like to take whatever arguments, or I guess whatever output we got from a command as arguments. And the way we're going to do this is by using a command called xargs. And xargs allows us to take the output of whatever, I guess, piping we've done, and take that output and put it and make it arguments to another program. So if we do xarg and then the program we're running, which is NeoVim, you can see that, and of course choose another file like parser.rs, it automatically starts, which is pretty nice. And that is, I guess, the first made-up example I put here. So let's take a look at the second made-up example I kind of made up with, which is, what if I was only interested in errors? So like I discussed in a previous slide, by default, everything kind of restores to standard out, which is like the file descriptor is one. And I'll talk more about file descriptors in a second, but you can see here, it corresponds to 1. So like I said, if I was only interested in errors, how would I get that? So let's take a look at another command, another utility called rg. And rg allows me to just look for patterns in files or directories. So what if I wanted to look at the pattern hello world in the directory /var? So as you can see here, it did find some patterns, but it also gave me some permission denies, OS errors, and I don't really know what that is. I just kind of want to look at hello worlds and tell my computer, and have my computer tell me hello. And the way we're going to do this is by taking advantage of file descriptors, specifically standard error, like I said. And so here we want to just like note down every error we got. So the way we're going to do this is by doing 2, which is the file which represents a standard error file descriptor, and then the closing square brackets like we said before. And I want to just output everything to standard to a file called errors.txt in my home directory. So now that we've, I guess, pressed enter, you can see that there are no longer errors once we run the command. But instead, if we do cat errors.txt, you can see that we got all the errors here. So that's the way we just like, we kind of specifically used advantage of the file descriptors to get the command we wanted. The cool thing about this, and also I wanted to note that I did kind of write a file, a table here, just to like note some of the commands you can do with redirection. But another cool thing I wanted to mention is that you can also, like I said, you can use piping and redirection at once, but you can also do multiple redirections at once. So we just kind of like did the example, we redirected standard error to a file, but what if we wanted to redirect standard output and standard error to the same file, or to, I guess, different files? So as you can see here, right, if we run this command, we're gonna redirect the errors to errors.txt, but we're not gonna redirect the the standard output to a file. We're gonna redirect it to, well, the default location, which is just to our console output. So we're gonna do this by using, I guess, the same trick. Instead of 2, we're gonna write 1, and then here we go. And we're gonna write it to a file called correct.txt. So once we've done that, as you can see, we got no output, which is a good thing, which is usually when you get, I guess, no errors, when your terminal doesn't tell you, when your terminal tells you, when your terminal does nothing, sorry, it basically means it's a good thing. Instead, if we check correct.txt, you can see that we got all instances of hello world in correct.txt. And I think that's a pretty cool example. Finally, I would like to note down that there's also this special directory / file called /dev/null. And if you basically write or redirect anything to this directory, the thing that will happen is that it will be discarded, automatically discarded. And if you're going to write shell scripts, it's pretty useful to look at. So now that we have gone over the basics, let's move on to actual shell scripting. And to do that, we kind of need to look at bash as kind of a language, which means variables and functions. So let's first take a look at variables. So to assign a variable, you kind of do like the variable name and then whatever you want to assign it to. So in this case, we're going to assign x to 1. And then we can do something like echo, and then to refer to the variable, we do $, and then the variable name. So if we do echo $x, we should get 1. And I want you to notice how I didn't do any spaces, or I didn't add any spaces. This is extremely important in shell scripting / bash, because if you add spaces, it doesn't refer to the same thing. And for another example, we can do something like strings equal to, well, hello world. And here we can put spaces because it's a whole string. So if we print out hello, I guess a string, we get hello world. Cool and handy. So now that we finish looking at, I guess, variables, let's take a look at aliasing functions. And you don't typically use aliases in shell scripting, but I do kind of want to cover them a bit because sometimes you might just need a alias instead of like a huge shell script or a function. And functions are usually, the way shell scripts are written. Like you have like a function that has logic, because like I said before in the beginning of the video, shell scripts are just basically a program that runs in a shell. So let's just get into it. So aliases, in a way, are just nicknames that can be expanded. So for example, I've been using the command ls a lot, right? But typically you would actually see this when you log into a Unix machine. You would typically see ls being with colors. And in reality, the way it works is that ls is typically, I'm saying typically a lot, sorry, is alias to ls.colors.auto. Now when we write ls, we can see that it has colors. Great. And here's kind of where the difference lies, all right? So legally, I guess the full name of this alias we created would be ls.color.auto. But the thing is, it really can't take arguments, or we can't do more logic than this. So even though aliases are cool, if you will run like a really long command, they really can't take more logic than is written in them, whereas functions, they can. So let's take a look at a function, and I will, here we go. The function I've written before is called caltex. And basically in bash, you kind of write functions like this. You know, you use the keyword function, the name of the function, and then whatever you want. And as you can see here, this is actually just a command you can write on the command line. But the difference is that it has a little more arguments here, right here. It has $1, it has $2. And you can think of these as placeholders. So if we expand them out here, and instead of $1, we can do hello, and then cat, we get this kind of fancy output, right? And I would be using, so to make this a bit more reusable, instead of like hello and cat, I created this simple function. Then when ran, I can just add parameters, and it will, I guess, take those placeholders as arguments to this, I guess, shell script. So once we source the file by using caltex, we can actually use the function inside caltex. And here would we say hello and cat as arguments, and now we type that. We can reuse the function constantly. Then we can change it however we want. You know, hello people watching this video, and as you can see, it's all good and handy. And that's kind of what I mean by when we look to compare between functions and aliases, right? Technically, we can alias this whole bit to a function, like we can alias the whole thing to something like this. And once I copy it down, sorry, we can just use hello, right? And it'll say hello. But the thing is, we can't really add arguments like we did in the function. It will always expand to this thing, and that's not exactly what we want. And I wanted to make that clarification clear. That's why I included aliases, even though they're not usually used. So let's move on. And as every language does, Bash has for and while loops, which I wanted to cover because you might use them a lot in shell scripts. And before I move on, I also want to say I'm sorry for the background noise. I really can't control it. But the syntax for loops is really simple in Bash. You know, you do a for, a condition, and then the keywords do and done. And between these keywords, you do whatever you want. So in this example, what we're doing is we're basically just printing out every number between 0 and 1 by echoing, I guess, the variable I. Another cool thing is that, a cool example that I would like to show is that by using for loops, we can do something like this. And I am just going to expand it out. and just explain what it does. Well, let's run it first and then I'll explain what it does. What this basically does is, between every number between 0 and 255, we're going to print out, and what this is basically an escape code. And escape codes are going to be a bit common if you're going to plan to use colors in shell scripts. Basically, we're telling, I guess, bash to use the escape code belonging to a specific color, and then the background to it by using expression, and then just echoing that. So when we echo it, the color of the text and the background of the text are going to be as we specify when we do that. And then we're going to use done. So basically, the for loop is between do and done. So it's going to be here, and it's going to be printing out the color in whatever color that is I. And then we're just echoing a new line at the end. And I think that's a pretty cool example of just what bash and for loops can do, because you can just get like this pretty example, although it's not the best in my terminal. And then there's also while loops. And while loops, I don't really use them a lot, but they are pretty handy. And then the syntax is also like, you do while a condition, do stuff inside the condition. And in this example I gave out, we what we're basically just doing is just incrementing x until it reaches 5. And before I move on to the next thing, I do want to give examples. There are two main pages that specifically kind of talk about this, shell arithmetic and then bash condition expressions. So I think I do have them right here. These are like kind of some expressions you can use in bash shell scripting that are really handy when you're trying to increment or decrement. And these are more expressions you can use when evaluating, I guess, conditions for your while loops, and then typically also shell scripts. So now that we're done looking at that example or the basics, I wanted to create a live demo where I will be, I guess, coding a bit to create a simple wallpaper picker. And what I mean by this is basically I want to create a script that's going to allow me to look at my wallpaper directory and just and make me pick a wallpaper to have my desktop change to. So let's just start. So as I said, I think one of the best things to do when you're creating a shell script is just plan what you're going to do. So I have a directory in my pictures directory called wallpapers that like has a bunch of the files I want to, or all the wallpapers that I would like to pick. And what I'm going to do is basically just going to, in this shell script, it's going to be a really basic shell script that all I'm going to do is basically pipe this into a program that's going to allow me to pick a specific wallpaper and then set it to. And the program I'm going to use to set my wallpaper is called xwallpaper. And I'm going to give it a zoom option to allow it to be completely just completely fill my, I guess, desktop. And xwallpapers just takes an argument, into whatever I want it to. So here we can see I completely changed my wallpaper. And that is basically what I want to do, but in a more fancier option. So let's just write it. And I'm going to call this, just going to call it script for now. And to create a shell script, what you first want to do is write this, a hashtag and then an exclamation mark, which is, I guess, in the computer science world called shebang, and then bin/bash. And once we write this, it indicates that this is going to be interpreted by, this file is going to be interpreted and run by bash. So like I said, we're just going to list all the files in this specific directory, and then we're going to have a choice. So what we're going to do is, again, pipe this into a program that's going to allow me to choose. Normally I would use FCF like I've shown you before, but the thing is FCF it only kind of works in the terminal. But there's another, I guess, program I use called rofi, and rofi allows me to do basically the same thing as FCF, which is to have like an interactive picker. So once I do that, and I'll give it a prompt called like pick a wallpaper. Once I do that, I can do that, except I also remember that I have to run another flag, and that flag is called dmenu. And once I give it to this, it will be able to act as a, I guess, a interactive picker. Here now, this is rofi, if you didn't know, and now I can do like, I can choose a wallpaper, and I'll print it in a terminal. And that's the basics of what we're going to do in the shell script. So let's do it. The way we're going to do this is by using putting art option or whatever you pick in the script as a variable. And the way we're going to do this is by using $, and then in parentheses. Whatever's in the parentheses is going to get expanded in bash, and then it's going to be assigned to this variable. So we are going to want to do ls that's pictures that wallpapers, and then we're going to just pipe it to rofi, and then do the dmenu flag, and then a prompt pick a wallpaper, right? So once we do that, and then we do gmod plus x, and then but basically whatever, if you want to write a script, like if you want to run a script, you're gonna have to make it executable. So if we do ls, right, ls-la, the script right here is only read only, and if you want to run whatever is in the script, you're gonna have to make it runnable. And the way we're gonna do this by using the command gmod plus x script. And then once we do that, we can call script. And here we have the most basic thing. And it doesn't print out anything to your terminal because it's gonna be stored in the chosen variable. Our end goal is just by using like wallpaper, zoom, -zoom, and then chosen. And we're just doing it in quote, I guess, in a string, just to make it more safe. And then we're, like I said, we're gonna add a bit of more safety. So the way we're gonna do this is just making sure that the input is not empty. So if chosen does not equal empty, then everything is okay. It's not empty, then everything's okay. But if it is empty, we're gonna just exit. And we're using the door here because the way OR works in bash is that basically if this is true, then it's gonna just run this. But if that's not true, it's gonna run this, which is gonna give us a true value after it exits. So overall, this will just evaluate to true. So once we write this and source it, and then we run the script, wait, hold up, and we write the script, and it is not a valid file. Here, you see, and this is one of the things I wanted to mention, right? Because as you can see here, we made a mistake, even though it was supposed to work. And we don't really know what the mistake is. But luckily, there's a utility that can kind of tell you how to make your shell scripts a bit better. And the utility is called Shellcheck. So if we feed in shell script, our script, it's going to tell us that we should use find instead of ls to handle alphanumeric file names. It's basically going to give us suggestions to make our script better. So instead of ls, we can do something like fd and then the period to symbolize that we're going to want to just look in the directory, all the files. So once we do that and we run Shellcheck again, it should be fine. And here, now our script kind of works. We can be using everything we want in whatever fashion we want. And that is a basic example of how to write like a shell script in your workflow. Like you should be thinking of how to write the shell script, writing it, make sure that all like anything that can go wrong won't go wrong by having some safety. And then using Shellcheck to make sure that your script isn't terrible. But that was a really basic sample, and that covers most of the, I guess, the things I wanted to cover today. But before I end the video, I want to cover or want to introduce 3 more things. I'm not going to cover this in the video, but I would suggest you to look into them if you're planning to do more shell scripting. And the 3 things are Cron Jobs, No Hangup, and T. So Cron Jobs are extremely useful because they allow you to, in a way, schedule a command to be run every certain amount of time. Like for example, you can make a cron job that will run every day at 12 o'clock to back up your server. And it's really useful if you're like system administrator, or like if you want to create, if you just want to like I said, back up all your files every day. Or if you want to, like, for example, I don't know, do something random and print out or remind, like give you a notification, you can do that with cron jobs. Another useful thing is called no holdup, or no hangup. Sorry, no hangup. It's a command that when you start, right, no holdup, and then you give it a command, it will run that command until it finishes, and it will be immune to it will be immune to like Control C, which is usually used to quit a command, Control C, and other things. Even if you log out, I believe that it will still be running, which is extremely useful, because you can imagine that you can have like a command that runs a considerable amount of time. For example, what if your backup takes more than, like, I guess an hour and you're trying to log out? You can use this command to make sure that it runs. And then if it has like some output, it will just write the output to a file. And it's very useful. And the last command that I would like to mention is T. It will kind of help you be more confident, because it kind of tells you, because you can see here, T allows you to kind of write standard out and standard error, but also have it be visible in a way. So for example, if I want to do ls dot ls right, and then I guess output everything to a file called file.txt like we did before, I can also do t-a and then files.txt. I will get the output of whatever the output of whatever we piped it into, but it will also write to the file. And this is kind of very useful, and just check out if you're doing, like, the piping you're doing is correct, because you can get the read, I guess it will also print out your terminal, but it also I guess redirect standard out to a file. And that's everything I wanted to mention. Hopefully you learned something, and have a nice day.